All right. Hello, everyone, again, and welcome to another weekly session where we talk about how to use Scrypt to program Bitcoin smart contracts. So today, we are going to cover the topic of, how do you verify a contract after you've deployed it? Okay. So before we go to the details, we may, one question people usually ask is, hey, what do you mean by verify a contract, and why do we have to do that? Okay, so basically, because Bitcoin is a so-called public blockchain, so whatever smart contract you deploy, since it's immutable, if anybody in principle, they can go to like a block explorer, like a Watson chain, and then look at the transaction themselves. They don't have to trust whatever the deployer of the contract says. They can always independently check the code, right? That's in principle. But here's the problem. In the transaction, you don't see the smart contract source code in Scrypt, right? Because it is being transpiled, it is being compiled down to so-called native Bitcoin script, which is like a bytecode, low-level assembly-like language. You can read, in theory, you can read all the script you want, but in practice, if you deploy any kind of a non-trivial smart contract, it's almost impossible for people who are not expert in Bitcoin script to understand the contract. So that's why we need to, if we, one of the most important feature, if not the most important feature for smart contract is so-called trustless and transparent, right? Because smart contract, once you deploy it, is immutable, and it's a public, so anybody can check. So to facilitate the independent verification, we want to make sure not only we know the contract in script, but also we want to know, hey, this script actually corresponds to this source code it claims to compile from. So the verify here simply means, if we look at this diagram, so you have the on-chain transaction from the Bitcoin network, and within the transaction, you can see the script, which is the deployed transaction of the smart contract. But also, you can, have the original source code ready, and what this verifier does is it simply compile this and see if these two versions match. If yes, then it has been verified. Does this make sense on a high level? What
Yeah,
does
yeah.
cool. So let's go through an example in this, So first we are going to do is we're going to deploy a transaction containing a smart contract, and then let's see how we can verify it using this block explorer. For us, we are going to use this Watson chain explorer, and because it has already integrated with Scrypt, so you can do the verification here. So before even we start the process, of course, the first step is, before you want to verify a contract, you want to deploy it. Okay, so you can deploy any of your favorite smart contract, but for here, we just walk through this Hello World example. You can also find it on the documentation here. So, this is just this is like what the name suggests. It's basically the very primitive smart contract, which you can deploy maybe without any prior logic, probably in less than 10 minutes. So let's walk through this tutorial actually. So first, before you go there, install all the required tool sets, for example, Node.js and also Git. So once you have that, and also install the Scrypt CLI. So let's even click there to see, just to make sure it's good. So first, install all these tools. I'm assuming if you are already into this series so far, you have everything installed. So we're going to create a sample project called Hello World. So after that, you're going to, go to the root directory and run npm install. So here, because to save us a little bit of time, I just run this command. I've already run, create a sample project called Hello World, and then I already finished the npm install. Okay. So this is a sample file. you can look at here. You have the contract here. You have this is the smart contract we are going to use. It's called Hello World. So what it actually does is very simple. So basically, you put a hash there, and whoever knows the message that after you hash it equals to this given hash, you can spend the coins that's locked into this contract. Yeah, it's very primitive example we are going to use this time. Okay. So this is our Hello World. Let's keep going with this one. This is the example I just showed you. Hopefully you can, if you are already into this episode, probably this should be very easy for you. Basically, you just check, if a given message, does it hash to the given value? I already stored, okay? If yes, the contract runs successfully, otherwise it fails, okay? So also to deploy it is also very simple. It's just a few lines of code, okay? Using our, updated API, it's just literally just one line, okay? So this is a sample, deploy script we just wrote here. So for here, I already created, and you can just copy paste the code into this, into this file. Okay, so you can see it's very easy. You basically, this is a contract we already wrote, Hello World. So you can import it after you compile it. You can, instantiate it, and after that you can connect it to a signer. We have talked about signer before. It's almost similar to a wallet purpose. So after that, once you have the instance and connect to a signer, is to deploy, just single one method called deploy, and then it's going to be deployed. And then to finish the full workflow, we also call its method here with the right value. Okay, so let's run it here. Run it again. I already run it once, but we can run it again. So basically, you can use this command, which is also listed in the documentation to run. Okay, great. This is a success run, looks like. And you can see here, the Hello World contract has been deployed in this transaction ID, and then it has been called in this transaction ID. So let's copy this transaction ID and go to what's on chain. And you can see this is, we already switched to testnet because we are deploying this on testnet. So you can paste the transaction ID in here. You can look at the details. So this already we finished the deployment. So I just run this command, right? So you can see this is a transaction that has deployed. You can see similar to here to the documentation here. So we just did it in less than 5 minutes. So once you have the transaction ID, you go to this site as I just showed you. Here you can come to this. You can also look at the on-chain script. You can see here, this is our contract, right? As you can see, even for this very primitive example, Hello World is kind of non-trivial, right? At least to me, it's just not easy to see what's happening here. Okay, can you guys tell me what this contract does by just looking at the script here?
Yeah.
Anyone?
Okay,
yeah, it's just
you can guess because of the explanation, but yeah, looking at the different topic codes, it will be impossible for me.
Yeah, you are almost like a reverse engineering from the compiled target to the source code. Okay, so that's why we need this tool here. So let's come back. So you can click. This is the smart contract we are dealing with. You can click here, and here, okay, this is the tab we're going to use. Basically, you click on the contract, the output that contains the contract, and then you're going to go to this page and then click script. So this is the plugin. Okay, here's the thing. So because this one was already being verified, actually let's try something not being verified. Okay, because this is already being verified because I'm deploying it again and again. Okay, let's try something different, which has not been verified. Okay, Just make it real. Okay. Let's see. Instead of saying hello world, let's say hello world, hello, hi world, let's say. Okay. Let's deploy again. So this time, because the contract changed a little bit, right? So then it's not going to be verified, but has not been verified. So let's see if this is the case. Okay. So again, search for the transaction. Again, this is a script we just have. We can click on the output again, and let's click to the script. Okay, yeah, that's good. It has not been verified. So how do we verify it? It's also very simple. First, you select the version. I think this is the latest we're using, so we don't have to worry about that. And then the next thing is also very simple. You just copy paste your contract code here, and then you check submit. Okay, if everything works, let's see if the demo god is happy with us today. If everything works, they should match exactly the code we just deployed. So you should give us, says this is matches. This is the source code that we just deployed, the contract. Okay, let's give it a few minutes. Okay, sounds great. And it looks like, the demo god is happy with us today. So it has been verified. And also you can see, it also shows the constructor parameters here. I think this is the SHA-256 of hi world. So previously we have the hello world. So we just change it a little bit. Now, anybody who has this transaction ID, sorry, they can go back. Let's go back. Okay. So this is a transaction we are coming from. So if you click again, and if you click here again, you can see the source code here. Only one person has to submit the source code and make it verified. After that, anybody who wants to interact, who wants to call the method for this smart contract, they can come here and say, hey, this is exactly the source code we are looking at. So as you can see, right, this is much, much easier to understand than just look at the raw script. But also you can also look at, what are the constructor parameters when the users deploy this. You can also see it here, and there's no way to cheat. Okay, you don't have to trust anybody. This is the source code. Okay, so you can trust. Okay, it actually here the logic is saying, hey, only whoever knows a message that hashes to this given hash, they can spend the money. Otherwise, you cannot. So, okay.
Is this verifying feature works only for Watson chain?
Yes, so far, because this one needs the support from the Block Explorer. So far, we only integrate with Watson chain, but it's also very simple to integrate with if there's any other Block Explorer who wants to integrate this. So basically, what it does internally is also very simple conceptually. So this is how it works. So you have the on-chain script, right? And then you can simply use our script.ts to compile the original source code and just do a simple exact match. If these two, are identical, then we know this source code is correct. Yeah, so far we only integrate with Watson chain because they have a plugin system. So we pretty much do everything ourselves by looking at the documentation, which is very good. I think it's somewhere, let's see. Plugins. Yeah, you can find the documentation if you want to have your own plugins, which is very nice. You don't have to go through everything on. Let's close this. Okay. Yeah, so far, yeah, only Watson chain.
Will it be possible to? Sorry, please go ahead.
Do you have to install this plugin to be able to use this feature, or a plugin should be installed only by the developers of smart contract?
Oh, you don't have to. We already deployed to Watson chain. So users, you can just go to Watson chain. You don't have to. It's there. Basically, if you go through this process, you can go there and check the script. You see here. This is not my local host. This is been deployed on production Watson chain. So it's already there. You can just go there. You don't have to download anything or
Okay,
install
thanks.
anything.
Yeah, in general, plugins, you submit the pull request, and when approved, it's available for everyone. Yeah.
Yes, exactly.
I have a question.
Okay.
So, could it be possible to have this, because you did it on the website? Could it be possible to do it on the command line? So you compile, you deploy the contract, and you verify the contract from the command line without. So next time you open Watson chain, it's already validated.
Excellent question. So if we go to our CLI, this is one of the next thing we are going to do. So basically what you said is correct. So here, you can always do it, right? If you deploy and then you go to Watson chain and follow this simple process. But here's the thing, right? You still have to go there and do a thing. It's even better if you can integrate it with all the, this process somehow automated with the existing tools, right? So that's exactly what we're planning to do. Basically using the CLI script, you can even say script verify, and then give it some parameters. So if this checks out, then you go to Watson chain, you're going to see, hey, this is already verified. So this is similar to the Ethereum world. So basically they also have this tool called Hardhat. So you can also do it, it's similar to our CLI. So once you install Hardhat, this is the developer framework. You can also do it from the command line, actually, as you just suggest. Verify it with the, you can deploy it. After you deploy it, you can also, verify this with the command line. Is this what you are looking for?
Yeah. That's exactly that. Thanks. That's
Yeah,
great.
exactly. Yeah, that's yeah, you are ahead of the curve. So that's great. And if you want to try this somehow, you want to submit a PR, you are more than welcome. So CLI is all open source. So this is on our roadmap, as you can see here, and you should come very soon, I guess. So this is much. So what would you prefer? What kind of scenario you want to use command line, and what scenario you want to use the browser? What do you imagine?
Well, to be honest, I thought that the one publishing the contract is the one that should verify it and do this manual process. Otherwise, it's the first user going to Watson chain, and maybe the code is not that available for them. So it simply looks more convenient to me that the guy that is publishing the contract is also verifying it. So you can do it on the same call, actually, right? So it's yeah, it's more for convenient, I'd say.
Yes, exactly. I think that's maybe I have not stated this clear. Let me make this crystal clear. So users are not supposed to verify. Whoever deployed this are supposed to be, as you just said, right? Whoever created this contract, they are supposed to have it verified. The users are not there. They don't, as you said, right? They may not even have the source code ready. They don't know where it is. They don't have it, and for them to trust it.
It's kind of bad experience if you go check the transaction, you see that it's not verified yet. So if you can publish and verify, in milliseconds, that would be better experience.
Yes.
I mean,
Yes, exactly. I think that's
Can
go ahead.
can anyone publish their plugins to Watson chain without like approval from Watson chain side or not?
You need approval, right? So
Yeah.
there needs some kind of access control. Otherwise, it's going to blow up very quickly. So everybody can create it, but to deploy on the production what's on chain, you need to have the approval.
Okay.
Yeah, I like the plugin system. It's very flexible because you just have the third party. They can develop whatever plugin they want. They don't have to wait for what's on chain to change. So this gives us a lot of flexibility. Yeah, I like the plugin system. So I don't have to, constantly ask what's on chain to add some new features just for my project. Same goes for every other project. So here you have, I think as a bunch of other stuff, you can have tokenized BMF, maybe somebody wants JSON, you can always see it here. You can also see the script. So yeah, it's a flexible system. Okay. Yeah, whatever I just showed you, you can find it in the formal documentation, verify here. It just shows the the process we just went through. Okay. Okay. Any other question?
No, thanks.
Okay, great. Seems this is a concise presentation today. Okay, great guys, and definitely try it out. If you have not, just play with it yourself and let us know if you want to have any improvements or like CLI to verify it, and also maybe some UI improve. Just hit us on GitHub and we'll fix it for you. Okay.
Yes,
Thank
out
you.
of curiosity. Yeah,
Go ahead.
one follow-up question, if you don't mind, just out of curiosity. So, this probably will check the hash of the contract or the compiled contract, probably. So, how sensitive is that? So, if the guy publishing the contract decides to add one new line or one more space, will that cause that the contract is not validated, or how sensitive
Yeah,
is that? How sensitive is that?
great question. So here's the thing, right? No, it doesn't matter because all this is a syntactic, right? So if you change it, let's say plug in this, the script would not change. You see what I mean? It's not, we're not matching the hash of the source file. We're matching the compiled output, the script output. So if you add a new line or add some new space, the output will not change. So it will still match. If the logic doesn't change, business logic doesn't
exactly,
change,
but
the hash.
the logic. So just imagine you put something in upper and then lowercase, and so it's the same, but the logic change slightly. That would cause a difference, right?
Yeah, the only way it does not pass the verification is you somehow change the source code that produce a different script. As long as the script is the same, you will match. You make the script, match the script, not the hash of the source code itself, which is prone to error, right? And also on chain, you don't have the hash of the source code also. So that's another reason. Yeah, but good point. Yeah. Another
No,
question?
that's the only one. Thanks.
Okay. Okay, great. Yeah, try it out. Definitely try it out. It's I think it's going to be used often, pretty much by everybody who publish smart contract that wants other people to interact with it. Because otherwise, users don't know, right? So you say, hey, I have this contract. If you, let's say, finish some puzzle, like a tic-tac-toe or Sudoku, you can redeem it. Then on chain, I can only see this so-called unreadable script. How do I know this contract is whatever you are saying it is, right? So whoever create this contract, they have a huge incentive to publish the source code. Yeah. For transparent reasons. Yeah, you can see this also in the Ethereum world too. Pretty much all the production ones, they have to release the source code. So there also you can verify it on their block explorer, usually on Etherscan. You do the same thing here. Okay.
Cool.
So these are Bitcoin equivalent you can think of. Yeah. All right, guys. enjoy the rest of the day, and hopefully see you all next week. Bye bye.
Thanks, you too.
Bye.
Okay, bye bye.